Hey juniors, I know you missed today for a field trip, but we still moved on in class in order for you guys to be able to do your test corrections in class this quarter, and there's 4 of them. We can't have any fluff days, so I had to keep moving on. I try to make this as detailed as possible. I encourage you to A, try the problems that I give you and then look to see if they match my answers. B, when I tell you to pause, stop, copy, write these notes down, I recommend doing that. And also I broke it down in parts. So notes, assignment, notes, assignment, notes, assignment. That way when you get done, it's not all 40 problems all at once. Alright, so let's try this out. Complex numbers. Complex numbers are, we're dealing with radicals that have negatives on the inside. And if you have a negative on the inside, if you were to push it in your calculator, you'd get a syntax error because your calculator doesn't read it. We, in the math field, we call those imaginary numbers. We say a radical of a -1 is I, and if you took a radical -1 times a radical -1, so if I took this times a radical of a -1, well, what would happen to your radical? They disappear, right? It's just like if you had radical 2 times a radical 2, that's really saying a radical 4, and that is the square root, perfect squared, and it would just be 2. Same thing. If it is radical -1 times a radical -1, that's really saying a -1 on the inside is being squared, and while the square root, that cancels out, it's just -1. Then I is not a variable. It is actually a symbol used for a certain number. So you always use I for imaginary. It's in pre-calc, it's in calculus, it's in any math classes from here on out that you take. So here's 3 problems. The first 3 parts are like your homework. I want you to copy them down and let's work them out. So the first one is a radical 81. What you always do first is pull at the -1. Radical -81 is broken up of -1 times a -81. So a -1, that is just I, because we just have the notes on it, that should be a plus right there, times a radical 81. Well, 81 is perfect squared, right? So that is times 9. So if I go I times 9, it is not I9. We always put the number first. It is 9I. Second, we have a radical -121 x to the 5th. Again, break it up in parts. It's going to be the easiest. Pull out your -1, radical -1, times a radical 121, times a radical x to the 5th. Remember, we have a variable. What do we do with variables and exponents? You have to divide that exponent by 2. That number goes on the outside with the letter, and then the remainder is on the inside. So let's see if you remember. Radical -1, and that's I, just what we learned. Radical 121, well, that's perfect square again. That's square root of 121 is 11. And then what's radical x to the 5th? Well, if I divided that by 2, it goes in there twice. It was x squared with a remainder of 1. Now if you multiply that all out, what's I times 11 times x squared? Write the number first, write the x squared next, and write your I last. Times a radical x. Our next problem is a radical -200x. Again, break it up. Take out that -1. Take out the radical 200 and the radical x. Now try to simplify it. This time, a radical I is still I, but 200 is not a perfect squared, right? But there is a perfect square as a factor in it. What's the largest perfect squared in 200? That is a radical 100 times a radical 2 times a radical x. Keep simplifying. I just stays I. Radical 100 becomes 10 times a radical 2 times a radical x. And multiply your common terms. I times 10, 10I. And then radical 2 times a radical x, that's a radical 2x. Now some of you said, I could have skipped this step, Miss Bratfold, and just gone here. That is fine. I just want you guys to get in your habit of writing down all of your steps for your test. Pause, copy these 3 examples down, and let's move on. Your computer's fancy version. Alrighty, I want you guys to try these on your own. So pause right now. And when you're done, resume to see if your answers match mine. Alright, hopefully you paused. If so, let's see if your answers match mine. Did you pull out a -1? Did you break 18 up with a perfect square, which was 9, and the factor of 2? And then did you reduce? And you said a radical negative 1 is I. A radical 9 is 3. And radical 2 does not break down, so that stays a radical 2. So we have 3I times a radical 2. And that is your answer. Did mine match yours? Hopefully. Alright, now you're trying your second one, right? So we had a negative 125x to the 5th. Pull out that negative 1 first, right away. Get in that habit. Then, what perfect square goes into 25? What's the largest one? Hopefully you said 25. And then 25 goes into 125, 5 times x to the 5th power. Now break them up. Radical negative 1 is I. Radical 25 is 5. Radical 5 doesn't break up, so that stays radical 5. Radical x to the 5th, remember you have an exponent, divide that by 2, and you would have had x squared on the outside with a remainder of 1 on the inside. Multiply your common terms. Outside the radical, I times 5 times x squared is 5x squared I. And then your radicals, radical 5 times radical x is a radical 5x. So, did your answers match mine? I'm sorry, I was really quick on that. Look to see, copy. If not, pause and look to see where you went wrong at. Alright, the next type are the cycle of i's. I's to the power of 2, 3, 4, 5, they all mean something. Well, we know that I to the 0 power, anything to the 0 power is 1. And we know that I to the first power is just I. Anything to the first power is just itself. Now, if I would go I squared, well, I squared is just like the first part of your notes when I showed you. It's a radical on the inside. The radical disappears, and that's a negative 1. Now, I cubed, think about it. I cubed is made up of, I cubed is made up of I squared and I1. If I was to say I cubed, ooh, that's a funky I. I cubed is the same as saying I squared times I1, because if I go 2 plus 1, that's 3, right? And I squared was negative 1. And I1 is just I. Well, what is negative 1 times I? Negative I. That's how they got negative I. Now, if I go I to the 4th power, and they said it's 1, well, if you think about it here again, if you can't read it, I to the 4th power was 1. Okay, well, I to the 4th power is made up of I cubed and times I to the 1st, because 3 plus 1 is 4. Remember, when you multiply exponents, you're really adding the exponents. So that is saying negative I, because that's what I cubed is, and I to the 1st power was 1. So what's negative I times 1? Well, they would cancel out the negatives, and you would have 1. And then you have I to the 5th power, which is I. Same thing, we could break it down. I to the 6th power, which is negative 1. I to the 7th power, which is negative I. We're not really going to probably go higher than to the 7th power. So I want you to copy these down so you know where they're all in your notes, because we are going to be referring back to them. Simplifying expressions. Alrighty. Simplifying expressions is just like in the radicals, what we did before. The numbers go together and the letters go together, obviously. If there were negatives, in the radicals, we'd have to do those first. Here, there's no radicals. It's just 8 times 3 is 24. I times I is I squared. Now look back on your notes. What did I say I squared really is? Negative 1. So what is 24 times a negative 1? That is just a negative 24. Copy, pause this if you need to, and let's move on. Number 5, it's a radical of a negative 5 times a radical of a negative 200. If you have a radical, you can't just, with the negatives, you can't just multiply those negatives together and let them disappear. You have to pull them out first. So if I pulled them out, it is a negative 1 times a negative 5. That's what this is, right? Negative 1, radical of a negative 1 is really I. So this, number 5, is really I radical 5. Same thing for radical negative 20, break it down. So I got a negative 1 times a radical 4 times a radical 5, because that's the perfect square that goes into 20. Well, radical I becomes a radical negative 1, I'm sorry, becomes I. A radical 4 becomes just a 2, and radical 5, that doesn't break down. So now I want you to multiply what you have on the outside. I, 2. Well, I times I is I squared, times 2 is 2I squared. And then you have your radical 5 times a radical 5, which is a radical, I squared, radical 25. And what's the square root of 25? And that is just 5. Keep going. What's 2 times 5? 10. So I have 10I squared. But what did I say I squared really is? Negative 1. So what is 10 times a negative 1? Ooh, negative 10. Now if you think about it, it's not as complicated as you're probably thinking. Oh my gosh, Miss Bradford, what are you doing? I want you to pause. I want you to copy this down. If so, I want you to rewind and I want you to watch it again. I bet it makes sense on the second or the third time if it didn't already make sense on the first time. It's the computer's version again. Just in case you can't read my handwriting, I always like to have this as the other possibility. Alright, I want you to pause, stop, and I want you guys to try it. Alright, hopefully you paused and you stopped. Let's see if your answers match mine. This is a negative 5I times 3I. We'll multiply your constants. Negative 5 times 3 is negative 15 times I squared. Again, I squared is negative 1. So what's negative 15 times a negative 1? Hopefully at the end you got a positive 15. Now your second one, I want you guys to pull that I out. So I want you to pull that negative 1 out on both of them. And I want you to pull that negative 1 out on the second one over here as well. Ooh. And I want you to go, oh, that's a positive 15. Sorry. And I want you to say radical negative 1, that's I, times a radical 6. I, ooh, Miss Bradford, what are you doing? This is supposed to be a 15. Times a radical 15. Now multiply what you have. On the outside, it's I squared. On the inside, what's 6 times 15? Well, that's radical 90, right? Can you break up radical 90? Is there a perfect squared in there? You bet. It's I squared times a radical 9 times a radical 10. Because 9 times 10 is 90. Well, 9, the square root of 9 is 3. The square root of 10 just stays the square root of 10. And we know I squared is really a negative 1. So we have negative 1 times 3 times radical 10. Well, what's a negative 1 times 3? Negative 3 radical 10. Did my answer match yours? If not, pause, copy, write this down, and then let's move on. Alright, this is your first part of your homework. I don't want you guys to watch the video. I want you to do your homework. Try to see as many as you can do. Hopefully you can do them all. And then I want you to finish this video. Second part is coming up. Here we go. Now we're doing equations with pure imaginary solutions. Look at this problem. It's very similar to what? I'm hoping you're saying it's very similar to difference of squares. Whoa, it's my mama calling. Okay, let's say if this problem was x squared minus 64 equals 0, you would have said, Miss Bradford, that's old school. I go x minus 8, x plus 8 equaled 0. Because if I was to FOIL this out, you would have had x squared minus 8x plus 8x minus 64. Does that match this? Well, yeah, these would have canceled out. And then you would have solved for it by setting both of your factors equal to 0. And you would have had x equals 8, x equals negative 8. But this is a plus. So I said we couldn't do them, right, at the time. Now we can do them. Alright, so if I wanted you to solve for that, get x squared alone. So you're going to minus 64 from both sides. If I do that, you have x squared equals a negative 64. Now, how do you solve for x? Well, how do you undo something that is being squared? You have to square root it So if I square root it, I have x equals the square root of a negative 64. What did I say? Can you have a negative on the inside? No, no, no. So what do? We pull up that negative 1, radical negative 1, times a radical 64. And what is a radical negative 1? We learned is I. And what's the radical of 64? We learned is 8. So I go I times 8, and hopefully you didn't say I8. You said 8I equals x. And that would be your answer. Alright, let's do the second problem we have. We have 4x squared plus 100 equals 0. So again, solve for x. I want you to subtract 100 from both sides. Hopefully this is just bringing you back to pre-algebra days. 4x squared equals a negative 100. Now notice both sides are perfect squares. So square root them to get rid of that x squared. So if I square root both sides, well, what's the square root of 4? 2. What's the square root of x squared? Just x. Now you have that radical with that ugly negative. So pull that ugly negative out. Negative 1 times a radical 100. And what did I say a radical negative 1 is? The whole concept today, I. And what's the radical of 100 perfect squared? 10. And we still have this 2x over here. So I have 2x equals, what's I times 10? 10i. And is x solved for? Heck no, heavens no. Divide by 2. So we have x equals 5i. So how'd you do? Did you follow it? Hopefully you did. If so, I want you to pause. I want you to copy those 2 examples down, rewind if you need to rewatch it, and then let's move on. Alright, this is the second part of your homework. It's just like those 2 examples we did. You might need to refresh your memory, and then after that, I want you to go on to your last part of your homework, but do not move on until you get this part done. Alright, simplifying. Now I have I to the 12th. And he said, Miss Bradford, you said we only go I to the 7th. I know, I said we only go I to the 7th power. I'm going to give you a shortcut. When simplifying i's that have numbers greater than 7, I want you to figure out where we are in the cycle by dividing that exponent by 4. And look at the remainder. So if I go I to the 12th, and you divide that 12 by 4, what's its remainder? 3. Alright, so if it has a remainder of 3, that's really saying I to the 0 power, which is 1. Oh, wait, hold on. I didn't explain that well. If I go 12 divided by 4, that's 3, right? Is there a remainder? No, there's no remainder. So the remainder is what you look at. So here it's I to the 0 power. And if you refer back to your notes, anything to the 0 power is what? 1. If it was 523,000 to the 0 power, 1. Alright, let's try this again because I confused you. What if it was I to the 17th? Alright, well, I to the 17th power, I want you to divide that by 4. How many times does 4 go into 17? Well, it goes into there 4 times with the remainder, because 17 divided by 4, 6, it goes in there 4, 16, right, with the remainder of 1. So really we're looking at what is I with the remainder of 1. Look back to your notes if you don't remember, and it's just I. Anything to the first power is just itself. Let's get you a little harder one. If you didn't like my chicken scratches, here it is with the computer's notes. Copy, move on. Here we go, 12. I to the 26th power. Again, I want you to divide by 4. So what's 26 divided by 4? Well, 4 goes into 26 how many times? 6 times. With a remainder of what? 2. Alright, so I'm really looking at what is I to the second power. You would say, I to the second power, oh, I know that one, it's negative 1. Perfect. So your answer would be, if you simplified I to the 26th power, it is really negative 1. Oh, are you getting it? Is the light bulb coming on yet? Pause, copy, before you go on. Make sure you understand. definitions of a complex numbers. Now I'm going to be multiplying and dividing any number in the form of a plus bi. Remember, I is not a variable. It is a representation of an imaginary number, where a and b are the real numbers and I is the imaginary units. We are going to add, subtract, combine like terms. So if I had 8 minus 3i plus 2 plus 5i, use your commutative property, and I want you guys to rewrite it with your common terms together. Meaning 8 goes with 2 because they were alike, correct? Negative 3, that goes with your 5 because they were alike. So now what's 8 plus 2? 10 plus, what's negative 3i plus 5i? 2i. Can you go any further? Heck no, heavens no, that is your answer. Because if you look back in your notes, I to the first power is just I. So that stays it. What about this one? Could you do this? Alright, rewrite it. What's your common factors? 8 and negative 12, those are alike. So rewrite them together. 8 minus 12. What's your next common factors? We got 7i and we have 11i. And notice they're both positive this time. Alright, what's 8 minus 12? Negative 4. What's 7i plus 8i? 18i. Now some of you might be saying, Ms. Bradfold, why isn't it I squared? Alright, reminder, if I was going back to my variables and I had up here, I'm up here now, if I had k plus k, you would say that is 2k because there's 2 k's. But if it was k times k, what would you say? You would say k squared. Hence why we don't change our variables. Going back to our pre-algebra days. And our answers match that. We're good. I want you to try this. Pause, try it, and then play it. Alright, hopefully you paused. If so, let's see how you did. Hopefully you combined 9 and 12, and there's that negative here. So you have to put that negative with that number. What's 9 minus 12? And then in your second one, you have a negative 6. So you got this negative 6i. And this negative carries out to this 2i over here. So hopefully you put minus 2i. And now what's 9 minus 12? Did you say negative 3? And did you say negative 6i minus 2i? Did you say it was a negative 8i? And leave it there? Awesome if you did. If not, pause, rewind, and see what you went wrong. Alrighty. Multiplying. I told you we're going to multiply. It's like foil, keeping math fresh. Alrighty. First, outside, inside, last. If I multiply this, what are my first terms? Well, you got to go 8 times 2. What's 8 times 2? 16. Outside, 8 times a negative 3i. Just like if it was saying 8 times 3x, you say 24x. This time we have an I. You said minus 24i. Inside, 5i times 2 plus 10i. And now your last, 5i times a negative 3i. Now we got 2 i's when you're multiplying. That is a negative 15i squared. And when we do that, let's simplify. Well, this is 16. I can combine these because they have the same exponent. Negative 14i. And now here, what did I say I squared is? Go back to your notes. Remember, I squared is like saying a negative 1 if you were to simplify that. Keep going. I got 16 minus 14i. Negative 15 times a negative 1 is a positive 15. Are we done yet? Heck no, heavens no. We can combine 16 and 15. That makes a 31 minus 14i. What do you think? Okay, I want you to copy. Here's the nice hand written by the computer instead of my chicken scratches. Notice we got the same as them. Yay! Alright, next problem. Copy. Let's see how you do. Negative 6 times 5, negative 30. Negative 6 times a negative 3i, positive, because 2 negatives make positive, 18i. What's 2i times 5? You would say plus 10i. you would say 2i times a negative 3i, that's a negative 6i squared. Now I want you to reduce negative 30. These are together. Let me make sure. Okay, plus 28i. And I squared, remember that's the same as saying 6 times a negative 1. And that's a negative 6 because I squared is really negative 1. So we have a plus 6. You can keep reducing. Negative 30 plus 6 is a negative 24 plus 28i. So it's the same concept as when we were multiplying our factors before, still using FOIL, still using the same process, now including i's. Yay! Alright, I want you to pause and I want you to play this out. I'm actually going to stop right here. This is the last part. Actually, there's one more part, but the video is pretty long. So play it out. See how you do. Try them all, because on Friday, we are moving on. And yes, seniors, you weren't in class, but you are expected to get this done. Adios, and see you Friday. Hi! What's up?
Good morning.